Hey there, my name is Miroslav Klivansky, Global Practice Lead for Analytics and AI at Pure Storage. Today, I want to talk to you about two challenges for analytics. Analytics has become a strong differentiator out in the market. And the reason why is it offers a number of advantages to customers that have matured their analytics and AI capability. What are some of those advantages? Well, based on research, companies that are advanced in analytics have 2.5 times higher customer satisfaction and customer experience scores. They have a 350% improvement in their operational capabilities. And they've also shown 46% higher rates of innovation. Industry 4.0 is all about adding data and analytics to the industrialization process and taking advantage of all of that information as you move forward. Getting there is possible, but there are typically two areas of challenges to address. What are some of those challenges? Well, when it comes to storage, they fall into two different categories. One are the challenges that come from distributed direct attached storage, or DDAS for short. The other one comes from siloed data. Today, I want to talk about those challenges in turn. Let's set the context with a little bit of a reminder. For all analytic applications, regardless of how they're structured and whether they're kind of batch-oriented or streaming, there's some notion of a persistent data store. Okay. So every analytic application has some way of bringing data into the application area, persistently storing it in the data store, and then having some sort of analytic engine that lets you query and report and access that data, right? And for a lot of traditional applications in the last 15, 20 years, the traditional way that these applications have stored data is with distributed direct attached storage. They had a number of nodes, each with direct attached storage. But as you can imagine, the nodes are not fully reliable and neither are the disks attached to them. So how did they protect data? Well, they took advantage of this capability or idea called sharding. And the idea is you would write a shard of data onto one node and then write a copy of that data on another node. So now the data is persisted on this direct attached storage. But, there are some challenges with that. And that's kind of where we're going to go next. The first challenge is in the area of disaggregation. And it's tied to this DDAS challenge area that I mentioned earlier. One of the first issues is that if you have a failure in your nodes or in your disks, now that second copy of the shard needs to be rebuilt somewhere else. And that takes time to rebalance that cluster. And you don't even really need a failure for that mechanism to trigger. It's very common for planned maintenance as you initiate what are called drains to empty out a node before taking it out of the cluster for service. So drains are also another operation that triggers rebalancing. Another aspect of these architectures is that they're wasteful. When you have an application or cluster built this way, and you need to grow, let's say, just the compute capabilities of the cluster, you end up bringing in disk that you don't really need. And vice versa. If you need more storage capacity in your cluster, but you don't need more compute, you still have to bring in additional nodes. So the third issue is they're wasteful. And finally, one of the things that you might notice is it's a cluster tied to a particular analytic application. So for every application, for every cluster out there, they have their own storage. And there's no easy way for them to share that storage. They end up creating silos. Each application is its own little island that's siloed the data that is stored directly there. And that takes care of the first set of challenges. The second set of challenges, as we mentioned, are the silos. So from a siloed perspective, when you have these silos of data, that means they're inefficient. You might have some applications that have lots of additional space, other applications that are running low. And when you're trying to manage these applications, you now have to manage, potentially dozens of different clusters and applications, all with their own management style, different ways of tuning, different ways of adding and removing capacity and nodes. That creates a heavy burden on the infrastructure team to keep track of how to manage each individual application and silo. So the first big problem is that they're inefficient. And the other issue is when each application is in a silo, but they're all part of the same analytic pipeline, you have to be able to get data from one application into another one, from one phase of the analytics data pipeline into another one, and that means copying. If you talk to data scientists, data engineers, some companies even have like a specified data wrangler persona. They can spend 20% of their day just setting up copy jobs and waiting for them to complete. That is a waste of valuable people's time. So that's the second challenge when it comes to analytics. So the best thing to do is to break down those silos and share the underlying storage infrastructure across your applications and pipeline phases. Pure Storage offers a small number of shared storage appliances that can each support a very broad range of analytic applications. FlashArray//X and FlashArray//XL are great when you need lots of performance, super low latency, and are working with scale-up applications. FlashBlade//S is awesome when you have a scale-out application and you need massive amounts of throughput. And then FlashArray//C and FlashBlade//E are the right platforms to match when you need cost-optimized storage that is able to be used for colder data or for archives. So keeping the number of platforms small makes it easier to manage the platforms that are there. With an abstraction layer, it makes the management even simpler. That abstraction layer can provide service level agreements and present your applications with classes of service. With Pure Storage Portworx, you can provide that abstraction layer for your containerized applications running in a Kubernetes environment. Portworx is a Kubernetes native platform for persistent storage and a number of other very powerful storage management capabilities. So to wrap up, today we've learned the importance of storage in analytic environments. There are two key solutions to the challenges that are common in analytics. One is to break down storage silos, and the other one is to disaggregate storage from compute. When you can do that with a small number of shared storage platforms that are easy to manage and allow presentation via service levels to the application, you can scale, you can deploy much more agilely, and you can mature the analytic capabilities of your organization. To learn more, check out the links in the description below. Thank you for watching.